Welcome to another episode of Science Made Simple. I'm Dr. Ryan, and I'm a science specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of kinetic particle theory. I have also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. The graph shows the changes in temperature with time when substance X is heated. However, the question did not specify the current state of substance X before heating. But not to worry. First, let us recall the changes in state and the associated physical processes. Starting with a solid, if you were to heat it up, it will undergo the process known as melting and transforms into the liquid state. If we were to supply it with even more heat, it will undergo the process known as boiling. Eventually, the substance will transform into the gaseous state. Are you able to think of another physical process that is also relevant to heating? Yes, that is sublimation, when you transform a solid substance to a gaseous substance directly. What our teachers in school have shared is that physical processes such as melting, boiling, and sublimation occurs at fixed temperatures. In particular, melting occurs at the melting point, whereas boiling occurs at the boiling point. Since melting and boiling occurs at fixed temperatures, we would expect the melting point and boiling point temperatures to remain constant. If we examine the graph below, we can see that the temperature remains constant between B and C, as well as D and E. This clue shows us that between B and C, the substance must have been undergoing melting, whereas between D and E, the substance is undergoing boiling. The melting point of substance X is 15 degrees Celsius, whereas the boiling point is 80 degrees Celsius. Going back to what we have drafted earlier, you should be able to see that below the melting point, substance X exists as a solid. Therefore, at stages A and B, substance X is in the solid state. If we were to use the same approach, we can see that above the boiling point, substance X is a gas. Hence, above 80 degrees Celsius, substance X exists as a gas. This also means that at stage E and F, substance X exists as a gas. Lastly, between the melting point and boiling point, substance X exists as a liquid, which means substance X is a liquid at stages C and D. We can see that from A to B, substance X remains in the solid state, whereas from B to C, substance X transforms from the solid to liquid state, while from D to E, it is transforming from the liquid to gaseous state. And lastly, from E to F, substance X remains in the gaseous state. Although this question might seem a little bit confusing, if you think about it carefully, smallest change in volume is in fact another way of asking you which stage involves smallest expansion in volume. To approach this, let me give you a clue. We have learned about the arrangement of particles in solid, liquid, and gases. What do you think are some of the keywords used to describe the spacing between solid, liquid, and gaseous particles? For the solid state, we can see that the particles are very close together, and there are very little spaces between them. Whereas for the liquid state, there are just slightly more space between the particles. Nonetheless, the increase in spacing is rather insignificant. And lastly, in the gaseous state, the particles are spaced very far away from each other. Well, how do you think the spaces between particles affects expansion? We would expect solid substances to expand very little upon heating, because there is simply insufficient space for the particles to move apart. On the other hand, for liquid substances, given the slight extra space, they will be able to expand a little. And lastly, for gases, because of the large spaces between the particles, they can expand easily upon heating. As can be seen, we would expect substance X to expand the least in the solid state, which means it will undergo the smallest change in volume if it remains in the solid state. Therefore, answer is option 1.
Thank you for watching, and I hope you have enjoyed this video.
If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!